will have a robust understanding of acoustic principles and their application in workspace design. And to start this session, I would like to invite Abdul Waheed, Managing Director, EYTE Technologies Private Limited, to start off the session. Thank you.
Hello. Hi, good morning, you all. Today being the last day of the exhibition, normally, like I was expecting this kind of scenario because I heard that there is some problem going on at the Central Railway and people are not able to travel. So, anyways, like whoever come will get benefited. That is what I mean. And like some recording sessions are also happening, so that will benefit others in later stage. So my topic today is acoustic that goes in workspaces. I'm going to talk about very specific related to workspaces. Acoustic is very vast subject. Okay, so basically, essentially, the AV field that we are into, the industry, audiovisual, is enhancing our experiences, and it is helping the communication, like making it effective, making it more efficient, making it more productive. The existence of human being is like the differentiating factor of human being compared to other species is like we can communicate. We don't only communicate through like the language, but there are other means of communication too. There are like there is body language, your facial expressions. So what AV equipments do is like making it more effective, making it more efficient. During pandemic time, what we have seen, the technology got a boom because everybody was working from home. And those days, like earlier video conferencing devices were there, acoustical concepts were there. We were selling many other products related to AV, but then like the acceptance in the market, except for the global client, it was not very much, especially for Indian client. But pandemic taught us like there were many restrictions. We couldn't go out. We used to be at home, but still world was running because of the AV and communication tool. Especially the video conferencing demand increase. If you see at the statics, I was reading one magazine where I read the sale of Zoom platform. Zoom is being used for video conferencing. In 3 months, it increased from 0 to 200. Okay, that kind of demand. We have seen schooling being done from virtual platforms. Earlier days, like the teaching faculties were hell-bent not to use the technology. Even it was so difficult to sell the projectors to them. But then like during those times, we've seen every education institute, every school, every classroom had to go on AV platform. They had to do, they understood the importance of technology that time. And during those days, like, now what we see the world is kind of a hybrid. Like, earlier the offices used to be the places where 100% workforce used to come and do the work. Then we heard the terminology called WFH, work from home, during COVID time. 100% work from home. So I heard during that time the companies like TCS and many banks, they have changed complete scenario and they announced that till 2025 we are going to be working from home only because they saw the benefit. Just on a lighter note, I will give you an example where I went to a bank, I will not name them, and during COVID time, it was peak COVID, nobody was allowed to get out of their home. I got special permission from the bank to visit their premises. I went there, and what I saw there is like, the office was completely ready in terms of whatever conditions the government has applied for any place to be ready for pandemic situation. So it is like the distances between the people, okay, 6 feet or so. So office space was converted into a working space for COVID times. So every seat was having 6 feet distance. They were having glasses all around the table. Every workspace was having 3 glasses. They were ready with this. The complete office was sanitized. It was ionized, that UV rays. And they had all systems everywhere. They have the ionized fan and sanitization machines. So it was completely ready. And I asked the chairperson of the bank that will you be able to, will you be inviting your workforce now back to the offices? And they said no. I said, why? You are already ready and ready to go for this, or to start this office now. He said, no, the benefit I'm getting, people working from home, is far better than people working in the offices. Benefit number one, they don't have to travel. It is their benefit. Benefit number two, I save on my electricity bill. Benefit number three, I save on coffee machines. Because these bank people, every time, like every 2 hours, they go and have coffee. I'm saving a lot of cost there. I don't have to have cleaning staff. Okay. I don't have to pay for huge rental spaces now. So many benefits they were looking at. And then he said, people in the office were hardly, they, of course, they come for 8 hours, but hardly they were working for 6 or 7 hours. Whereas work from home, now they are working for 8 to 10 or 12 hours. 100 more than the 100% efficiency. So this is what I'm getting. I will not going to invite them. But then time passes and then we saw 100% work from office to 100% work from home. Now it is a hybrid mode. So offices are now meant for a hybrid session. Some people come on few days, they don't come on other days. And when they come, it is mainly for collaborative kind of meeting, collaborative sessions, kind of meetings with clients, meeting with their colleagues. So only for those things they used to come now to the offices. So offices, the design of offices has changed drastically. Okay, in the newer concept, what you will see is more of meeting rooms, less of office desk. Even the desk become hot desking. It is a common desk where anybody can come and sit. I hope you know like what hot desking is. Hot desking is kind of a IoT session where you will have IoT sensors on the table. I can book my desk. Like for example, this guy has to use this space. He will book on the app that I will come and sit. So if I am coming, I can see like out of 20, now only 18 spaces are available, 2 are blocked. I will see where my colleague is sitting. I can book that desk and I can come. The hot desking also become very common terminologies nowadays in hybrid offices. One more important topic came up, which is my topic today, is acoustical parameters. Earlier days, nobody used to understand the importance of acoustic. We used to talk about acoustical fencing, acoustical treatment of the wall, sound absorption, reverberation, but people were never paid any attention to these subjects. They said like, okay, I can hear it, it is okay. But during COVID time, when everybody were using video conferencing call, and like somebody cannot hear them properly. I know this term became very common. Can you hear me, sir? Am I loud? Am I audible? Is my content being seen? Are you seeing my content? Are you seeing my laptop? So those things, the terminology has become very common because during video conferencing, it was only audio and video through which you were able to communicate. And then people, the bosses, especially bosses of the offices, understood the importance of why acoustical treatment, why proper audio is important. Because you loses your efficiency, you loses your interest, you get tired. Continuously sitting on the call and disturbing sound is very irritating. It makes you tired very early. So that was the thing people started. Even like, during the class lecture, the teacher used to stop and say, hey, Anish, tell your mom that wo cooker ka 3 सीटी हो गया hai. Stop it now. So that kind of audio, like, were creating disturbances. So when these crowd, these offices, these people came back to office, they realized that our office needs to have proper acoustics. I do AV and acoustic both. So this is the subject, like, we are going to, before that, I will just tell about myself. We do AV and acoustic both, okay? So I have seen post-COVID, people asking me for acoustical consultancy is more than what they're asking me for other things, AV or IoT. They're calling me more for acoustic because they understood now. Every room, every meeting room, whatever best equipment you put in, you have to have proper acoustics. Without acoustics, it won't work. Maybe best of this thing, it's not working. something wrong with this. Just a sec. So now what I was telling you is, in spite of having best of best AV equipments, like I can have best DSPs of the world, okay, best of best video conferencing equipment, best of best speakers, best of best mics, but it won't work if you don't have proper acoustics. Okay, so this subject is also becoming very important for us to learn, especially the AV people. They should know what goes in acoustic. So there are certain parameters that you need to understand. Okay, for example, I'll give you one simple example. When I'm speaking, okay, there are a lot of noises coming from surroundings. Okay, a lot of ambient noise, people walking around. Some people are playing loud music. Some announcements are happening. Maybe if you are next to the road, there will be traffic noise also you will be hearing. So all those will be distracting you. And I'm speaking in front of you. But being human, you are able to focus on me because your brain is filtering out other unwanted sounds. Okay, and our ears are also designed that unwanted frequency gets filtered out automatically. Okay, the hissing sound, the unwanted frequencies we don't want. But when it comes to microphone, okay, microphone is a dumb device. It is just electronics. It understands only dB. Certain dB, it has to pass it on to the far end or other end. Okay, it will pass it on to amplifier and the speaker. It will further amplify it and make it more loud. So microphone doesn't understand what is the difference between human voice and the AC noise. Okay, so it has to, we have to have a device which filters out all those devices. We call that as DSP, digital sound processors. So what a audio programmer will do, he will go and he will see there is some AC noise coming out. This is not wanted. He will calculate that frequency. He will in the program filter out, cut down that noise, and he will send only the remaining sound. Maybe some canteen is there and continuously some voice is coming from there. He will measure the dB level, he will cut down. Okay, he will sometimes what happens in a boardroom, some people whispers. So mic is not supposed to capture that sound when I'm talking personally with my colleague. Okay, so certain dB level I can define, if I'm speaking to you, I have to be loud enough so that certain dB level, maybe around 50, 55 dB I have to be speaking to you. So I can define in the DSP programming that only if audio is coming 55 dB, we human being speaks between 20 hertz to 20 kilohertz. Okay, our frequency is captured. So we want only that audio to be captured when it is human vocal voice. So we can program it, define it in the DSP that this only sound can go on the far end. This gives quite clear sound on the other end. But still after doing that also, there are a lot of other things that is to be addressed. Okay, one is there are certain concepts in sound. So it came directly on. So this is how audio helps us. First is reduce stress, and as I said, during the COVID time, we had faced all these problems. Already because of the lockdowns and those things, our stress level was high. And then when we were attending calls, not able to hear, it adds to your fatigue. And it also if we have proper acoustics, we can collaborate more effectively and more efficiently. And our performances also increases if we have better acoustics. So there are some challenges in offices, in office workspace design. One is architects always want the office to be designed beautifully, look beautifully. They are always, their perspective is aesthetical looks. Okay, so for good aesthetical office looks, they will go for glass meeting rooms. And glass is very dangerous for audio. Okay, whatever I speak, it bounces back. Audio is an energy. When I speak out, it has to die down. If it is not dying down, it will hit the surface, come back. Okay, this is called echo. If I tell you something, one is direct sound hitting your ears, one is indirect sound hitting that surface, hitting this surface. And especially if it is glass, hard surfaces, you will get more reflections, reflective sound. You will get more than one sound. So that is reducing the clarity of the sound. Okay, you are not able to hear me clearly because you are hearing now more than one sound. So basic principle is when I speak, that energy after hitting your ear has to die down. It should not be there in the room again. Okay, so that is clear sound. It is sound clarity, intelligibility. You should be able to hear my words and understand it. Sometimes we hear, but we don't understand because it is so much of humming, so much of echo, so much of external noise. So you have to pay a lot of attention and you get tired because of that. Okay, so one subject is speech intelligibility. That has to be taken care in the meeting room. And how it happens? The audio energy that comes out of your mouth, after you heard it, it has to die down. It will die down only, it won't die down completely, but you have to have absorptive material around. Maybe the soft carpet, maybe some beautiful soft hoardings on the sides, maybe some soft paneling. This is what we do in acoustic. So one thing is for sound clarity, it has to die down and we have to absorb it in the surrounding so that it doesn't come back. It increases your sound intelligibility. Okay. Second concept is like, now we are sitting in the room, whatever announcement being made is distracting us. Why? Because the audio is interfering. Whatever I am speaking is going out, whatever noise is outside, I'm hearing it out. So I have to isolate it. It is called sound privacy. So I have to restrict my sound disturbing other areas. Okay, especially if it is a meeting room and next room is cafeteria, lot of noise will be there. Cafeteria, you cannot go and people to follow discipline and not to make noise. And normally cafeteria will not have carpets. It will have hard surfaces. It will have open ceiling. They will not beautify ceiling by acoustic treatment. They will keep a open ceiling, fancy look. Okay, and of course, like, they are cooking something. They cannot have fancy ceiling. It will get spoiled. So they will always keep hard surfaces, open ceiling in the cafeteria, and it's going to be very noisy. So as an acoustic consultant or maybe as an AV guy, when we come in and we see like the MD cabin next to cafeteria or a boardroom next to cafeteria, we should be able to point out this and tell our client, sir, you have to relocate this space to somewhere else. Okay, next to cafeteria, boardroom, meeting room cannot happen. Because whatever best acoustic you have it, still you will get disturbance. Because it is directly proportional to the cost. I can stop the sound. I can make this room very silent, but then it will be matter of cost. You will be increasing the project cost. That I would not like to have. So one is sound clarity within the room, and second is sound privacy. If it is an MD room and he's talking to some client, that audio should not be heard by the office staff sitting next to his cabin. So I have to make sound privacy. These two topics we always try to take care in the acoustical subject. So background noise, ambient noise, like, HVAC system, office equipment, printers are there, and then some vacuum machine, somebody is cleaning the office, and all those create lot of disturbances. Okay, if your office is next to the road, lot of traffic noise. Even like, when we do the sound testing, we have to make sure that there is no aeroplane or train passing by. For example, if this is the office, Nesco office, they are going to already have the metro passing by and the highway. So all those noises will come inside. So we have to stop outside noise coming inside and increasing the ambient. Because, in silent room, I can speak very well. If the ambience level is low, there is no disturbance, you can hear me very clearly. That is what we heard, always hear that pin drop silent. Even if a pin falls, we can hear it. But if ambient noise is more, okay, especially in cafeteria or a noisy railway station, on an airport, ambience level is up high. We cannot hear that pin drop because it is already very noisy. So you make the office space more silent, you can hear the speech very clearly. This is what is like background now. Second is speech intelligibility. I told you, you should be able to understand the words coming out of my mouth. It is also called articulation loss. There are certain levels, like, 10%, 15%, 25%, 0% you cannot achieve. You will always lose some part of my voice. Like, I'm speaking and somebody is announcing. So some of my word, because we are intelligent human beings, we connect the dots. Like, you may connect, like, some word I might have spoken, you might have not heard, your brain will fill in. Okay. So there is articulation loss also. So these are the three fundamental subjects of any office design. The office has to be silent. Okay. It has to have room privacy. And third is, these are the thing what we do. So how we define, like I spoke about zoning and partitions. If I'm next to the cafeteria, how can I stop that sound coming to my room? Okay. One is, like, I directly tell the architect to shift this office somewhere else because the cafeteria is next to my office. One is simple way. Second is still, like, there is no way, like, in Mumbai real estate space is very high, very costly. So then we can tell them, okay, then we restrict the audio. How do we do that? We add partitions to stop the sound. It is called, like, how do we measure the thickness of the wall? Is called STC, sound transmission coefficient. If I am speaking at, for example, if I speak loudly, right now maybe it is 85 or 95 dB, you have the smartphones, you can see, like, maybe it is 80, 85 dB. But if I play a loud music, it may go up to 100 decibel level. So 100 decibel level, I am playing a music here, it will be definitely heard in the room next to me. So how can I stop it? By having good partitions. So partitions, like, they can stop half of the audio, 20% of the audio, 30% of the audio. This is how we calculate the sound transmission coefficient. We play an audio here, 100 dB, okay, white noise or pink noise, because this is transfer easily and can be calculated on the equipment. We play 100 dB noise, we go to the next room and measure it. If it is 100 out of 100 is coming, if I'm playing 100 and you are hearing 100, that means there is no partition, sound transmission coefficient is 0. Okay. If I want to, I'm playing 100 decibel and I'm hearing 80, my sound transmission coefficient roughly is around 20 STC. Okay. If I'm playing 80 dB, I'm hearing 30. 30 means you cannot hear. Okay. Above 45 normally only you can hear. Okay. So that means I'm stopping 50 decibel, which is good enough. So STC 50, STC 45, STC 35. This is how we design office partitions. Because to have more STC, the partition has to be thicker. Meaning, like, I will have gypsum layers, I will have some frame, wooden frame, I will have some glass wool inside, some absorptive material that stops sound going in the other room. But doing that is a costly affair. The thicker the partition, the more is the cost. So we have to play, like, very optimum. When we design offices, we make sure, like, partition comes to around 40, 45 STC for office design. That is doable. An architect do this, like, by having gypsum layer, some wooden partition, some glass wool, and again same repeated here. So we define the cross section. So this is how we do sound privacy. My audio not going out. This is one. For glass, glazing, if it is exterior wall, we did for L&T, Mahape, wherein the entire office building is of glass. And it is just next to the road. So we did lot of acoustical testing, what is ambient level. And then how do we do that in glass? We have to add one more layer of glass. And in between these two glass layer, we keep some space. Audio or any energy cannot pass through the vacuum. So we kind of create a vacuum between those two glass layers. Okay. And thickness of glass again is a cost. Okay. So 12 mm, and in between we keep some 10 mm or maybe 5 mm glass, 5 mm glass. Space in between is 10 or 12 mm. That way we stop the outside sound coming to the office. So this is one way. Second is sound absorption. As I said, like, whatever I speak, after you heard it, it should die down. It should be absorbed somewhere. So in the meeting room, what we try to do is If it is glass surfaces, it will hit the wall and again create an echo effect. And especially it is very dangerous when you have audio equipment inside, if you have microphones or video conferencing. And it is normal and common in any offices, meeting rooms, video conferencing device will be there nowadays. Okay, so mic will absorb all kind of echo, and then you will always hear a complaint from far end that I cannot hear you properly. There is some echoing happening. So how we address this? One is DSP, I said. I measure all the unwanted frequency, cut down in my machine itself. Second is how I design the office acoustically. One is carpet. We have to tell the client that you have to have soft carpet in the office. Soft material absorbs the sound. So whatever energy is being spoken, getting absorbed. Out of two surfaces, two parallel surfaces, one surface has to absorb it. Because if you have two hard surfaces, it will keep on hitting. If I have two hard surfaces, floor and the ceiling, it will keep bouncing. So one surface, if I neutralize it, if I make it absorptive, then my problem is half solved. Okay. So one is carpet, second is acoustical ceilings. Okay. Many offices will have open ceiling kind of concept or hard ceiling, where it is very dangerous. Architects normally go for open ceiling concept, where you can see the wiring, ducts going on. They beautify it also. They will give them natural look of brick. In those cases, it becomes very challenging and difficult for us as acoustical consultant to guide them. So there are acoustical island also available. Sometimes we suggest. And normally what happens after the entire office is designed and now people have occupied it, they start coming and using it, and they start getting complaint from their far ends or people using the devices. They will complain like audio is not. Then they will call acoustical consultant and ask them what can be done now. What can you do if everything is ready? So then in those cases, there are acoustical islands are also available. We place some soft boards, some absorptive material on the ceiling hanging. Looks beautiful also, not affecting the aesthetical aspect of the office, and then solve our purpose, functional aspect also. So one is this, out of the two surfaces, we have to make one surface absorptive for audio to be better. Third concept is sound masking. Many call centers, okay, they sit next to each other. Every single one of them is talking on the phone, okay, and they're talking to their client. So in that case, what happens is, I told you, if ambience level is low, you can hear each other very clearly. So what you have to do in that case, you are sitting next to each other, talking on the phone continuously, we have to increase the ambient level. Okay, I get distracted because whatever you are talking, he is hearing. Okay, he gets distracted because he is not able to concentrate. Now to make his life easy, I have to make you unintelligible. Okay, he should not be able to understand what you are speaking. So I will increase the ambient level. How do we do that? We add speakers. It is called sound masking. We add speakers, sound system, amplifier, and we play a white noise. Okay, there is attenuator that should not disturb the human body. We create some artificial noise being played. It is kind of sound. Okay, if you come, you will not notice it is some sound is already there, but it is increasing your ambient level. So by doing that, you will not be able to hear him. He will not be intelligible enough for you to get distracted or disturbed. So this concept is called sound masking. This is widely done in all global offices, offices in US, Canada, and UK, because it is cold countries. Okay, the temperature is very low. They don't run the air conditioning in their offices, so ambient noise already goes down. Okay, they turn off their AC. They don't use AC because it is already the temperature is very low. So there, sound becomes very clear. So they have to add artificial sound using sound masking system. Even in Bangalore, some of the offices uses it. The problem is during winter, when they turn off the AC, all of a sudden office become very noisy. And then they said boss, wo sound masking kaam nahi kar raha hai. Then we go and realize that because of the winter season, they have switched off all their ACs and fans. So that artificial noise is gone down. So ambient went down and now they are finding office very noisy. This change happens. So that time we have to go and attenuate and increase the sound masking level. In Mumbai, Delhi, it is not commonly used because the temperature is very high. People always use AC, which is always giving HVAC noise, is good kind of a sound masking itself. So we don't need that in these regions. So these are some of the acoustical material. I told you acoustical islands we use in cafeteria. If office design is already done, we can use these kind of ceiling tiles or islands. Acoustical panel. One simple thing of audio is like more surface area difference. You create more surface area, one. Second, you create more grooves. It is like how you design, you think of water, okay? It is a liquid. How it will get leaked. Whatever ways it get leaks, the similarly audio will get leaked. If you have all these curves or lines in between the panels, water will go inside. Similarly, audio go inside and get stuck. This is how you kill the audio. Acoustical furniture. Telephone booths are being widely used in office designs now. Because when you are on telephone, you are talking somebody who's on the speaker, you are not able to calculate how loud you are speaking, how much disturbance you are creating in the office. So we create this kind of booth. Sometimes if it is a plain small booth with hard surfaces, still audio will come out. It will leak out. So what we do, we put acoustical panel inside. So whatever you are speaking very loudly, that also get absorbed within that cabin or the capsule. So these are the two fundamental things which I spoke about: sound clarity and sound. Speech masking system I have already spoken about. Okay, how do we this thing? Acoustical partition. These all things like, how do we calculate? So if a space is given to us, so we have to create simulation diagrams. There are softwares which create like, exactical kind of a digital twin of the space. Okay, there like, we define how much audio you are going to have in that particular room. And then you design like, if it is going to be 100 dB, 125 dB, then you calculate like how much of, like we coordinate with architect what kind of surfaces, what kind of material they are using. After getting that information, we see like if that audio is getting absorbed in that room or it is still there. That way we calculate like, each simulation diagram gives you what kind of audio distribution we are getting in the room. Okay. One more concept is like, there is first class seating. I have speakers this side. Okay. First row will hear me very clearly. If it is large room, okay, and speakers are only in the front, rare people cannot listen me carefully. They will tell you, we are not able to hear you, increase the audio. If I increase the audio, that will create the disturbance for the front row people. Okay. So how do we address this? When we design our office design or any workspace design, especially auditorium and training rooms, we should not give first class treatment to some people and then the last bencher don't get that experience. We have to have uniform experience throughout in terms of audio, in terms of video also. You might have had some lectures on video, like, if this big screen, some people in the end last pair will not be able to read the text. So as a consultant, as a acoustic AV engineers, we should give the uniform experience that the text should be readable till the last person. The screen size and height should be such that you should be able to get the same experience as you are getting in the front seat. Similarly, for audio, you should be able to get the same experience, the last person and the first person. How do we achieve this? So that is what we do in this simulation diagram. We draw how many speakers. There are array speakers. The array speakers one below other. What do? Like they have different angles, throw angles, and the dB levels. If I have to achieve 85 dB here, then the array speaker, the top speaker, we will design and direct in such a way that it will direct the last person and he also hear the 80 dB level. So you get the uniform experience. So this is all what we do in simulation diagram. Similarly, in simulation diagram, what we do is how much dB level we are creating in the room. and how much absorption we have to do. Accordingly, we have to design the absorptive material for the same. So this is how we design and do in each simulation diagram. And then our solution should be well integrated for lighting also, because lighting nowadays it is LED. Still they give some kind of sound is there, transformer. Earlier days it used to be incandescent light or tube lights, and then the transformer also used to create kind of hissing sound. So all those things are also be taken care while you are designing acoustic of any office. HVAC is the major contributor of room ambient noise. Sometimes it gives 65-80 dB, which is not acceptable. Even the manufacturer claims that it is like less than 40 or 45 dB. It is not. It is factory or lab tested reports that they speak about. When it comes to the actual ground, actual offices, they give more audio, more noise, and create a lot of sound, especially when we do studio designs. Studio are very skeptical, very susceptible or accepting all kind of sound. You might be knowing that we have addressed NDTV, continuously some noise is coming, and we found out in spite of doing best of acoustic in the room, there was HVAC which is creating continuous noise, and when anchor is speaking and channel is recording their session, there is some noise coming in. So HVAC is the major contributor that has to be taken care. So what we do, when we design any office, we have to coordinate with HVAC consultant, electrical consultant, architect, to have the proper office design, which is we give you best results. So conclusion is you have to take care of all these things, research, properly do when you are designing any office, just to see if airplane is passing every 10 minutes. So you might have not thought about it. You have thought about the environment around you. You have thought about the office space and the floor and the building and the traffic, but you forgot that there is airport also nearby. So you need to do proper research, conduct some site surveys, initial audio, what is there, and then design your acoustical treatment accordingly. You plan properly, okay? What kind of architect wants the office to look beautiful, and you are engaged for functional aspect of it. You have to coordinate with them. You cannot disturb their complete architect's intent or architect's theme. You cannot disturb. You need to come talk to them and get proper planning done. And implementation, this is something which I want to speak and elaborate further, because in implementation, I told you it is treat audio energy as water. So I did best of best designing, best of best calculation of office partition thickness. I did correct absorptive material. But during implementation, the door guy has left some spaces. Okay, he did not, the workmanship. He did not do the proper door alignment, audio is going out. Then client is still complaining. Some electrical guy came and he wanted to put some electrical socket. He punctured the wall. So inside he did not close, only outside he put that faceplate. So the audio is leaking. Sometimes in the ceiling, everything is done beautifully. Above the false ceiling, nobody have bothered to close the partition above. So we have to tell the architect, that partition should be from true flooring to the true ceiling. Normally what they do is false flooring to false ceiling. Is done properly, but above the ceiling, audio is going next to the room. It is as is. We have had practical experiences where I'm speaking here and equally heard in the next room. So next meeting room is useless. One space, just one order we have got, a government project in Navi Mumbai, wherein they have designed 3 training rooms, but using only one. Because if I'm conducting a training program, nobody can work there because my audio is directly going in the same dB level as if in this room. What they do, the mistake is same, they did not close the partition above the false ceiling. So simple mistakes. So implementation also becomes very important. After doing all these things, you have to go and still do the testing. What kind of reverberation you are getting in the room? Are you getting the proper STC? If not, if your design is proper, your e-simulation result was proper, implementation was proper, something else might have happened, some workmanship errors, somebody has punctured the hole, did not close it. So all those aspects we have to take care if you want to have a good workspace acoustically designed, then like you get better achievement, better results, better efficiency. People don't get tired working in your office because audio create a lot of disturbances. Okay, even the RT level absorption should not be too much. This is where e-simulation also helps. It is where like you need to have acoustical consultant, because if you have too much of absorption, if the room is very silent, you cannot sit there. You have overdone the absorption, especially when you go to theaters. Okay, and if nobody is there in the theater, you are sitting alone. I bet you cannot sit there for more than 10 minutes because it is pulling the energy, it is sucking the energy back, and you hear some kind of uncomfortable. That's why in the auditoriums, banquet halls, and the theaters, they will play the background music because it is acoustically well treated for 100 people. If one single guy sit there, he will feel tortured. Sometimes you go in the boardroom, meeting room, you are waiting for the interview, there is nobody, and you feel uncomfortable. You cannot sit there for more than 5 minutes because it is too much of absorption. You cannot have too much of absorption. You need certain kind of ambient level. You need some dB levels always having it. In the dark room, you can sit for hours, but in silent room, you cannot sit for minutes. In fact, like, for tortures also, like, they create 0 dB rooms, 0 ambient level, and you can go on YouTube and check, like, people cannot, they have, like, they are challenging each other to sit in that room more than 5 minutes. They cannot sit. They use it for torture. People become very uncomfortable. So dead rooms are something being used for torture. So it is very important for us to design the room correct, with correct ambient level, correct privacy level, correct sound and absorption materials. Thank you very much. If you have any question, I can take 1 or 2 questions. I have 4 minutes left. Is it? If no question means I have spoken it very well, or you might have not understood anything. Thank you. Thank you very much.
Thank you so much, sir.
And sound masking उसमें काम नहीं कर रहा है, then you go and stimulate the increase the dB level, correct? तो उसमें real time sensor कुछ काम नहीं करता, ऐसा कुछ?
There are systems like the modern attenuator that is coming. Sound masking is very different, a very interesting subject also. So there are like attenuator and calibrator. One is mechanical calibration. You can do the mechanical calibration frequently, and especially weather wise. So you go in summer and you do the calibration, you get a different reading, you attenuate and set it at a different level. In the winter time, when like people will switch off, turn off their ACs, and then the audio level will further go down, you have to increase you can do it mechanically, and there are IoT systems also. Some dB sensors are there, and then you can do it automatically also. There are companies, especially in the other hall, there is a company called EYTE. They do a lot of sound masking. They have Atlas sound here.
One more,
And they have
soft DB is also there.
Sorry?
Soft DB.
Yeah, soft DB is there. BIAM also do this. And now they are coming up with a second level of sound masking. Earlier, we used to play this very dry white noise, okay, which is hissing sound basically, correct, which is not very comfortable. Like, at a certain level it is okay, but if you increase, you don't like hissing level. So now they came up with the concept of having natural music, water sound, bird sound, air sound. And then they have done research. You can go on EYTE and ask the sound masking team. They have some natural sound they play in the offices, and they have done the surveys and research and found out that this natural sound, natural water sound, natural bird or wind sound increases your efficiency as a human being. You like it, and your efficiency is also increased. They done some surveys on this. Okay. So they have those mechanisms.
Thank you, sir. Thank you.
Any other questions, ladies and gentlemen? Okay. I shall call Mrs. Smita Rai to give away a token of appreciation for this wonderful session by Abdul Waheed. Audience, can we have a huge round of applause for this session?
Thank you, Smita.